selecting a motor, you really want to know the torque and the RPMs. Decrease the speed by a ratio of 10 to 1, the torque also goes up by 10 to 1. Open loop is where there is no encoder feeding back to your controller the position. If you're going to run this thing 24/7 and you want to run it at some optimal speed, then a VFD on the AC motor is a much better choice. We do a lot of automation projects, and the question is always, so what kind of motor are you going to use? So we're going to talk today a little bit about what you do to select a motor. So the two things that are important in selecting a motor, the first one is torque, which is the force that the motor can exert in a circular direction. And then the second one is simply RPM, which is how fast the motor turns. So one of the issues with doing things with motors is that most motors are way too fast for most of the things that we want to do. It's very difficult to drive things with a direct drive in a lot of cases. And the reason for this is that in the case of AC motors, the motors are operating at a speed proportional to the line frequency. And so they tend to run at 1800 or 3600 base speed. And then when you are dealing with DC motors, the voltage that is supplied to the motor has a lot to do with the speed of the motor. So in the past, if you needed speed control, you went with a DC motor because it was the simplest way to get variable speed. But nowadays we have what they call VFD, variable frequency drives, and they're very good at making AC motors run at different speeds than the base speed. And depending on how good a drive you're using, you can actually get down to as low as 1/100th of the base speed. So in the case of an 1800 RPM motor, you could technically get the motor all the way down to 18 RPMs. Now, that is where the torque comes in. The torque is the amount of force the motor can put out at any given speed. Well, if you slow a motor way down, the torque falls off. In a DC motor, the torque tends to be constant to quite a low speed, like maybe 10% of the motor's base speed. But when you use a VFD, the torque falls off a lot faster. And so one of the things you can do to run a motor much slower with a load is to use a bigger motor. So torque times RPM equals power. And motors are frequently, lefty. Motors are rated in power, horsepower and so forth. The reality is the horsepower is not really a useful number because it equates to something. But in selecting a motor, you really want to know the torque and the RPMs. The power is kind of the final element. You're going to find out how big a motor you need based on torque times RPM that you're working with. So those are the important factors that come into every motor selection. And so the next thing becomes, can I run this device at a constant speed, or do I need variable speed or even variable torque? And so that kind of starts splitting things down. In the past, if you wanted variable speed, it was pretty much pushed you into a DC motor right out of the starting gate. That's not so true anymore because we can make variable speed motors that are using a variable frequency drive. So that becomes a big part of it, is what kind of speed control you need. So lots of things like conveyors and such, typically they are not varying the speed. They run the conveyor at a constant speed, and if you want parts arriving at a certain time, you basically put them on the end of the conveyor at a certain rate, and then they wind up at the same spacing when they get out the other end. But so that can be done with a constant speed motor. However, the motor is always too fast, so you wind up using a gear reducer to get the speed down where you want. So in conveyor applications, you're almost always using some kind of gear reducer, and that, of course, affects the torque. If you increase or decrease the speed by a ratio of 10 to 1, the torque also goes up by 10 to 1 on the driven load, which means that you can pull a lot more weight. When you're picking a motor for a conveyor, you're going to back into it. You're going to say, how much force do I need on the rollers pulling the load, or divide that by the gear ratio, and that's going to tell you how much torque the motor has to put out. So again, you can use a DC motor to get speed control of the conveyor, or you can use a variable frequency drive or other kinds of motors like servos or steppers. Other things become a factor, and one of the big ones is cost. And all of the different motor technologies have a different cost associated with them.